Token Turing Machine is a sequential autoregressive model with external memory. It is particularly designed for streaming visual data, such as human action videos, as well as robot task videos. The key of Token Turing Machine is that it interacts with memory by reading and writing. Instead of digesting the entire video sequence as an input, it looks at local segment at a time while benefiting from memory interaction. Such memory utilization is repeated at every time step. This allows Token Turing Machine to have a constant time complexity as opposed to previous transformers. It achieves better performance while requiring significantly less compute. Now, let us talk a bit more about details. Token Turing Machine could be viewed as a modernization of neural Turing machine, which was designed to process a sequence of long inputs. We are modernizing neural Turing machines by using transformer as a controller and by implementing memory as a set of tokens. We can also view Token Turing Machine as a recurrent neural network, where all its components are implemented with token-based operations. More specifically, we can view it as a RNN with transformer plus token learner. In the case of previous transformers, when a long video input was provided, we had no choice but to feed all of them as an input and process them all together, requiring quadratic amounts of computation with respect to the number of tokens. On the other hand, as we discussed, Token Turing Machine processed such long video input one segment at a time by utilizing memory interaction. And it applies such memory interaction sequentially, ultimately capturing temporal structure. Here's more detailed architecture. At every time step, the transformer in Token Turing Machine receives tokens as a result of the read operations from memory and inputs. Once the processing is done, Token Turing Machine not only generates the output, but also tries to take advantage of such output and everything to update the memory based on the write operation. Such updated memory is provided to the consequent time step, sequentially modeling the temporal information. The read operation is implemented with token learner, which could be viewed as a soft selection of tokens. We provide memory tokens and input tokens into a single pool, and we make the token learner select multiple tokens out of such pool and provide it to the processing unit, which is a transformer. For more details about the token selection in token learner, please check the paper. Memory write mechanism is implemented similarly to the memory read mechanism. We formulate memory write as memory rereading. By dumping output tokens, memory tokens, and input tokens into a single giant pool, and making token learner to select informative tokens out of such giant pool, we reformulate the memory. If there are memory elements which were important, token learner will learn to reselect them and give it to the new memory. If there are memory elements that has to be discarded, token learner will learn to not select them. All these operations could be written in recurrent neural network format. And as we have been mentioning, we can view this as a RNN implemented with transformers and token operations. We tested Token Turing Machine on trace dataset for human activity localization. We are able to see that Token Turing Machine achieves state-of-the-art by modeling temporal structure on top of video VIT. We also did an ablation more explicitly comparing Token Turing Machine with conventional temporal transformers. And when these approaches are taking advantage of the same number of tokens, we are able to see the clear computation benefit of Token Turing Machines. it also performs slightly better. We confirm this with another dataset, ABA dataset, where we are forced to do spatiotemporal localization. Compared to the previous way of utilizing the memory, token Turing machine definitely showed superior performance. We also evaluated token Turing machine for robot action policy learning. We took advantage of the dataset from Robotics Transformer 1, which contains 700 robotics tests done with 13 robots over 17 months. For such challenging robot control problem, token Turing machine showed superior performance compared to other transformers not taking advantage of memory. Token Turing machine represents and processes a sequence of many tokens. It is a generic framework. It's a recurrent transformer with token-based memory. If you want to find out more about token Turing machines, please come to the poster. Thank you.